All right, so we're going to look at 2.7. We're going to take our parent graphs. Well, actually, we're going to work at just some generic graphs, but we'll also look at our parent graphs from yesterday and start doing some transformations on those. All right, so let's kind of start with just getting some notes out of the way, and then we'll jump in and do some actual examples of these. Now, what I have here is I have a g function. And the g function is actually just some kind of a transformation of my f function. So I kind of put this to make it stand out. F doesn't really mean anything. All it's telling you is, hey, this is just some sort of function. It might be a quadratic, it might be a cubic, might be a square root, might be an absolute value. The process is the same in all of those scenarios. When you see these parentheses right here, those actually might be absolute value signs. They might be a square root. They might have a little squared up here. And so we look at these are inside grouping symbols, whatever those grouping symbols might be. So let's look horizontally. Anything that is tucked inside those grouping symbols is tucked in here with the X. And since it's tucked in with the X, it will affect your graph horizontally. So I know you've done some of this transformation stuff in previous classes, so hopefully I'm not going to spend a whole lot of time here going through all of this. But the H value right here, whatever you're adding or subtracting inside the parentheses, that is a shift. So it's going to shift left or right here. I don't know if you want to write that here. Maybe you just know that, but it's a shift, horizontal, so left or right. All right, so the B, which is inside here, it's a coefficient on your X. That's going to be a horizontal stretch or shrink. If the B happens to be a negative, then that's going to be a horizontal reflection. So if you think of something reflecting horizontally or sideways, then it actually ends up reflecting over your y-axis. Now, the thing that's special about anything inside the grouping symbols, anything that deals horizontally, we always do you remember this from Algebra 2? You always do the opposite of what you would think. So when this is a minus sign and you feel like it should go left, nope, it actually goes right. The bigger that this B value gets, if it's a 3, a 4, a 5, that feels like it should be stretching your graph. But nope, it does the opposite. It actually shrinks. So everything inside grouping symbols, we're going to think about doing opposite. All right, let's talk about vertical transformation. Anything that is away from this X, so that would be this A value or this K value. And just to FYI, the variables I chose can change. There's nothing that sticks me to an H and a K and an A or B. Different textbooks use different variables for that. But ultimately, this number way out front, this number way out the end is not caught up with the X. So those are outside the grouping symbols, away from the X. So then that would affect your graph vertically instead of horizontally. The K out there at the far end, that is a vertical shift. Again, remember the H was a shift. Whatever you add or subtract is going to be shifting it. But this time it's going to shift it vertically, so it's going to go up or down. The A value, which you're multiplying by, just like the B was a stretch or a shrink, the A is a stretch or a shrink, but it's a vertical stretch or shrink. And if A happens to be negative, that's a reflection, but it's a vertical reflection. So if you think of something flipping like upside down or flipping vertically, that means you would be flipping over the x-axis. Now, nothing special. I mean, you do what it says. If this is a plus, we go up. If this is a big number, we stretch. If it's a fraction, we shrink. And probably the stretching and shrinking is the trickiest part of this. So I wanted to take a moment, let's just review that just a little bit before we jump in and do examples. So in these first ones, I just want you to recognize, should this be a horizontal stretch or shrink, or should it be a vertical stretch or shrink? Remember, horizontal is an X thing, so it's going to be tucked inside the grouping symbol with the X. Vertical is not. Okay, so for this particular function, whatever that f of x function is, do you see how the 3 is tucked inside there with the x? That means it's a horizontal thing. But remember also that we always do the opposite. So where it feels like it should stretch by 3, it actually is going to be shrinking. So I would write that as a horizontal shrink. You might use that word compression. That's okay also. By, and I don't really say that it shrinks by 3 because that feels like that should be getting bigger. It shrinks by a third is what that would do. It's a third as wide because it's a horizontal shrink. It's a third as wide as it would originally. Okay, let's look at B. Look at where that 4 is. Do you think that's a horizontal or a vertical thing? It is away from the x, not in there with the x, so that means it's a vertical thing. And we do what it says. So this is a vertical. It's a bigger number, bigger than 1. So it's a vertical stretch by a factor of 4. It's 4 times taller than what the original function was. All right, last one of these. A little trickier. I threw a fraction at you. Notice where it's at. It's tucked inside with the x. So that means it's a horizontal thing. All right, but you do the opposite. And since this is less than 1, and I do the opposite, so less than 1 would make me think shrink, but nope, it's going to be a stretch. So this is a horizontal stretch. What do you think it's going to stretch by? It would be the reciprocal of that. Over here, when it was a 3, we put a 1/3. So here, when it's a 2/3, it's going to stretch by 3/2. So that's like a 1.5. So it's 1.5 times wider than the original function. All right, so now here's kind of a quirky thing that you may or may not remember from Algebra 2. But if you have multiple things going on inside of those parentheses, so up here, I just had the one thing. I just had the 3, or right here, just that. I wasn't adding or subtracting. There was no negative to worry about, nothing like that. So now when I suddenly put that B value in there, but I also have some sort of horizontal stretch or shrink going on, I have to factor that B out first before I decide what kind of movement is going to happen. So when I factor out the B value here, it's going to look like this. I'm going to factor the 3 out, and then it would be an x minus 4. And that actually is what you base the shifting on, is after that 3 comes out of there. Because that k value that I have on that previous slide, that only works really if this has a coefficient of 1. So I didn't want to make your notes real cluttery with that little concept, so I waited and pulled it in here. So what I would say on this particular transformation is the 3 was on the inside, and this 3 is actually going like right here. When I pull that 3 out, it would go right there. It doesn't suddenly go outside and turn into a vertical thing. It does not do that. It's still a horizontal thing. But I'm going to do the opposite of what it says. So I'm going to say that it's a horizontal shrink again by 1/3. It's 1/3 as wide as it used to be. And the 4 is a horizontal shift. I'm going to do the opposite. So where it feels like it should go left, nope, it's going to go right. 4 units, not 12 units, 4 units. Okay, let's try that one more time. Maybe I'll let you try this next one. Go ahead and factor out and decide what you think the transformations will be. I'll go ahead, or if you would go ahead and just pause the video, kind of try that one on your own. All right, so here's what I've got. I pulled out the -2, which is not only going to change that horizontal shift number, but it also changes the sign on it. So the negative is going to be a horizontal reflection. So that means it's going to reflect over your y-axis. It reflects sideways. And then, since that's a bigger number, but I'm doing the opposite, it's a horizontal shrink by 1/2. And then because the sign changed and I factored that 2 out, it's going to go right 3. All right, let's jump in and do some examples then. Now, I'm going to start off and I'm just going to do some that are just kind of funky little functions of some sort. What I want to do with these is I actually want to kind of identify the key points on it, which we do with any kind of a graph. I'm going to look at all these like little vertices, and I'm going to do the transformations on all 4 of those vertices, and then I'll redraw this picture. So looking at the function that they've given me, I had some sort of an f function. Now my g function is a transformation of the f function. So let's go ahead and list out what we need to do. Now I haven't said this yet, but it is important that you do your transformations left to right. Sometimes it changes your graph, and so it is key when you list out what am I supposed to do, I'm going to do it as I read the function left to right. I did that on the previous slide. I just didn't draw your attention to it. All right, so here we go. On this one, the negative that's out in front is away from the x. So that's a vertical. Well, and usually I don't even write the word vertical. You can say it's a vertical reflection, but usually we think about a vertical reflection means that it's going to flip upside down. So we'd say it reflects over the x-axis. So that would be the first thing I would have to do. Now, this 2, because I have multiple things going on inside here, I do need to factor that 2 out. So it's really going to be like this. And one more time, just to clarify, this 2 is actually sneaking in right here. It is not coming out in front of the F. It's still a horizontal thing happening right there. So that's a horizontal. I feel like I've done this a few times. It's a horizontal shrink because I'm doing the opposite by 1/2. And then it's going to go right 3. Now what I do is I take all 4 of these ordered pairs over here, and I'm going to do those 3 things in that order. So here we go. Let's start with this one right here. This point is going to first reflect over the x-axis. So that means right here's my x-axis. Since it's down 3, it's going to pop up and land up 3. So now it's here. And I love that I got this pointer thing. It's easier to do this than on my Promethean board, but it's because I'm just going to track it. And you're doing the same thing with your pencil tip. You're just saying, okay, now I'm right here. The next thing I have to do is I have to shrink horizontally by 1/2. So I'm talking about like from the middle. I am currently right here. I am 2 units out. I want to be 1/2 that. So I'm really only going to be 1 unit out now. And then the last thing I have to do is I have to take that point and I have to move it right 3. 1, 2, 3. There's my new dot right there. So I'm going to grab a different color here, and that way I moved right. I reflected and then I moved right 3. 1, 2, 3. Right here is where I landed. All right, we're just going to do that with all the points. Here we go. Next point, this one right here. First thing you're going to do is you're going to reflect it over the x-axis. Okay, it's currently up 5. I'm going to reflect it so that it's down 5. Right here I am. Next thing I want to do is shrink it horizontally. I'm currently right 2 units of the middle, so now I want to be 1/2 that. I'm only going to be right 1 unit. Okay, and then I'm going to take that ordered pair right there and go right 3. 1, 2, 3. All right, let's try again. This one. Okay, first thing I do, reflect over the x-axis. So that was up 5, so I'm going to be down 5. Okay, now this is a little trickier. It's a horizontal shrink by 1/2. If you look at how far out you are right now, I am actually, this didn't come out quite as nice, did it? I am over 7 right there. And I want to be out 1/2 that. So that means I have to be out 3 1/2 from the middle. So that's okay. I'm just going to estimate it kind of right here at this 1/2 mark. But then I got to take that point and go right 3. 1, 2, 3. It's going to land right there at, what is that? Over 6.5, down 5. Okie doke. Last point. This one right here. First thing, reflect over the x-axis. So it is currently up 7, so it's going to reflect down so that it's down 7 right here. I was just counting this. I think I chopped this off a little bit. Okay, hang on a second. 1, 2, 3, 6, 10. Okay. 9, it is. It's only 9 down. That was throwing me off a little bit. Okay. All right. So then when I come down here, there's my 7 mark right there. Okay. So I reflected it. Now I'm going to shrink it horizontally. I'm in luck here because this one is actually over 8. So if I'm over 8, I want to be half that. So I'm going to only be over 4. And then I'm going to take it and move it right 3. And there's my ordered pair right there. And then you go connect all those points. And hopefully you can see that, yeah, it looks like it's flipped upside down. And it looks like it should be skinnier, like it's not near as wide because it had a horizontal shrink to it. And then it also moved right 3. Okay, we're going to try one more together, then I'm turning you loose on one. Okay, so on this one, first thing I want to do is kind of list out the order of what I need to do. So the 2 is the first thing that is outside of the X, so it's a vertical thing. I do what it says, so it's a 2. It's going to be a stretch. Oops, started to write shrink though, didn't I? It's a vertical stretch by 2, so it's going to be twice as tall. The negative that is on the inside here, that's a horizontal thing. Now, I did say that I should factor that out, but because I don't have a number, it's all about this thing happening over here. If that's not there, factoring the negative out, or even if it was just a number, factoring out isn't really going to change anything. It really just changes this shifting. And so I'm not going to mess with writing it factored out. I just know that it's going to be a horizontal reflection. If something reflects horizontally, it's going to reflect over the y-axis, reflect sideways. And then the -3 is outside, so that's a vertical thing. And so it's going to, I can say a vertical, but how about if I just write that it's going to go down 3? All right, let's do that with all 4 points. First thing I'm going to do, this one, vertical stretch. So now I'm looking at from the middle vertically. I'm currently down 3. I want to be twice that. So I'm going to be down 6. I'm going to reflect it sideways. So that means over the y-axis. So this point is now over here. And then I'm going to go down 3. 1, 2, 3. New point lands there. All right, here we go. This one is at 2, 5 currently. Let's see what happens to it. First thing, I have to stretch it by 2. Oh, okay. It's twice as far up there. So now it's up to 10. Got it? Reflect it over the y-axis. Uh-oh, I'm going to be in trouble here. Reflect it over the, well, maybe not. We'll see. We'll see what happens. Reflect it over the y. So now you're over here. And then down 1, 2, 3. Okay, let's try another point. This is going to be kind of similar. It's a vertical stretch by 2. So instead of being at 5, it's going to be at 10. It's going to reflect over the y-axis. So now it's over here. And then I got to go down 3. Which sort of seems right that it lines up nicely with that. And then your last point, this is the one I kind of think I'm in trouble on, because it is currently up 7 from the x-axis. I have to vertically stretch that by 2. Eek, that means I'm up at 14. That's off my graph. That's okay, I'm just going to hover up here. I'm up at 14. And then I'm going to reflect over here, boom, still up at 14, but I get to go down 3. So that would take me to 11, which is just a little bit above that. I can live with that. So I'm going to just sneak in a point right there. Okay. And then let's go ahead and connect those dots. And you can see definitely has a vertical stretch to it. It's much taller and it's flipped sideways. And then it looks like it's up, but it's really down because that happens after the vertical stretch happens. All right, last one of these, but I need you to kind of try one on your own. This one shouldn't be too tricky because you can see that the ordered pairs are all kind of at similar locations. So you're kind of practicing that same move a couple times. There is quite a bit going on right here. Remember, you have to do it left to right. So the first thing I want you to do is make a list right here of what transformations you have to do. And then go ahead and do the transformation on this. Pause the video. All right, here's what I have. Hopefully you have that same thing. One thing I did forget to mention, and I'm kicking myself here, this one did not have any horizontal B value to factor out. So I didn't have to mess with changing anything here. This just went left 5. Nothing tricky on that. But I had forgotten to mention that you should probably go back to your notes and make a comment on that slide that has the fancy border with your horizontal transformations. And you should probably make a note somewhere on that slide that you have to factor the B out. Because I'm not sure that I kind of had that slide later that said it, but maybe you want to have that on your main notes slide. Okay, let's keep moving. Now, honestly, this is really more of what we're going to be doing than just having funky graphs. We're going to be using our parent graphs, our parabolas and our cubics and our square roots. We're going to be doing these transformations on those. And I kind of do those just a little bit different, but the idea is the same. We usually first, you have to know that parent table. That's why we spent a whole lesson on those parent graphs, is so that you would know the shape of that. You should know that an absolute value is a V shape and it just goes over 1, up 1, over 1, up 1, over 1, up 1. You know, it just has a nice slope of 1. Okay, you should know that a parabola has a vertex at the origin, and then the shape of that is different. It kind of gets steeper. It's over 1, up 1, but then it's over 2, up 4, over 3, up 9, that kind of thing. You need to know those before you can be transforming them. So what we're going to start off is we're going to look at the table that we know of our parent graph, and then we're going to adjust that table for any stretching or shrinking that we know should happen. All right, once you have your table adjusted, I'm then going to do the next thing, which is shift the vertex according to your H and K. So that vertex that normally is at 0, 0, we're going to shift it to its new spot. And then we'll use the table we did to plot our points. Now, I say that like I'm not plotting like going through and running points through the equation to plot them. I want us to be more efficient than that by now. So we're going to plot based on our table, taking into account any stretch or shrink or reflection that we decided there should be. Okay, let's try it. Now, I kind of put this to-do list up here just so, well, for me to talk through, but you know, it's probably super tiny. You probably can't see it in your notes. That's okay. Go back to the previous slide. All right, so here we go. Just left to right. I know that this right here is going to be a reflection, like a upside down reflection. So that flips over the X. So reflect over X axis. This one is going to go right to, this is going to go up 1. Okay, I'm kind of in luck with this one because I don't have any stretching or shrinking going on. So this might be an easy enough one that by writing that, I think I might be able to graph this without having to make that table. And that's great. That's sort of where we're going. We're trying to be efficient. It's a V shape. The vertex that's normally at 0, 0 is going to go right to and up 1. So this is the new vertex. It's still the same old V shape, just where it has a nice slope of 1 on either side. The only thing that's different is that it's going to be upside down. I don't think I need a table to show that. I'm just going to draw it upside down. So instead of going right one, up one. I'm going to go right one, down one. I'm not going to go over 2, up 2. I'm going to go over 2, down 2. And I always go back to that vertex as I'm doing this. Over 3, down 3. And honestly, I could do this all day long. Well, not all day, but I typically on the absolute value, I'm going to make a jump and I'm just going to go like, let's go over 6. 1, 2, 3, 4, 5, 6. Down 1, 2, 3, 4, 5, 6. I like to get a little bit away from the vertex. That helps keep my graph a little bit more accurate as it continues down. All right, let's go ahead and do this other one also. It would land right there. Okay, there's your transformation. All right, the next one will be a little bit trickier for us. So this 2, that's a vertical stretch by 2. This is going to take it left 3, and this is going to take it down 5. Okay, so if you think of, I don't think you have a bunch of space on the right, but maybe you have to put this on the left, but I'm going to put it right here. You have to think of your parent graph, y equals x squared, and think about what that table was. If you put a 1 in for x, you get 1 back. If you put a 2 in, you get a 4, 3, 9, 4, 16. I'm starting to get off my graph there a little bit, so I'm going to stop there. But ultimately, I go back to what this said. I'm going to have a vertical stretch by 2. If this is going to stretch vertically by 2, that is going to affect all of the y values on my graph. So all of these y values are going to be twice as much as what the parent graph is. So I take all of those times 2. Now, if you feel like you need to write the times 2, so that's now a 2, 8, 18, and 32, that's fine. Ideally, we could maybe just do that in our head, just trying to be more efficient. All right. I don't have any reflection, so this is just a normal upward parabola. And I'm going to take my vertex and I'm going to shift it left 3, down 5. Right here. Now from there, I'm going to use my table to make the shape of this parabola. So where I would normally go over 1, up 1, the table is now telling me to go over 1, up 2. Over 1, up 2. So you put a dot there instead, and then put the matching point on the other side. Then I'm back to my vertex again, and instead of going over 2, up 8, instead of 2, 4, I'm going to go 2, 8. So from the vertex, I go 1, 2, and I'm going to go up 8. Right there. And then I put my matching point on the other side. Do you think we could fit one more in there? The next one would say over 3, and instead of going 3, 9, because, and again, you kind of have to remember, these are just the squared values. That's where that's coming from. And then so you just know that instead of 3, 9, it's now a 3, 18. Okay, I think I'm going to end up way up here somewhere. So I'm going to call that quits and just graph it from there. All right, so that's sort of our process on our parent graphs. Let's try one more of those. All right, first thing I'm going to do is kind of list out what the transformations are going to be. So I can see that this is going to reflect over the x-axis. The next thing is that 3, and that's going to be a vertical stretch by 3. And then the last thing it's going to do is it's going to go left 5. All right, so I've got 3 different things I'm going to deal with. Now, my next thing is to get ordered pairs from the parent table on this. And so thinking about what a square root function looks like, hopefully you remember, it kind of has that look like it's a sideways parabola thing. But I'm going to be picky about what I plug in for x on my table. If I put in a 1, the square root of 1 is 1. But I don't really want to put in a 2 or a 3. But wouldn't a 4 work great? The square root of 4 is a 2. What would be the next number that would work great? 9, 3. How about 16? 4. All right, so we don't always need all of those, but sometimes it's helpful to get to that 16, 4 number. All right, so now what I'm going to do is I'm going to recognize that, all right, this is a reflection over the x-axis. So this sideways parabola thing that I'm thinking is actually going to reflect and be upside down, and it's really going to be on the bottom part instead of on the top part of that. Okay, so let's keep that in mind. The other thing that's going to happen is it's going to have a vertical stretch by 3. Since it's a vertical thing, it's going to affect all the y values here. So I'm thinking in my head, all right, all of the y values are going to be 3 times more than they used to be. So I'm going to take all of those times 3. And then I'm going to also need to have this thing go left 5. All right, so once I've sort of acknowledged what's going to happen here, then what I do is I get my vertex pinpointed in the right spot. So the only shifting off of the origin is to take that thing left 5. So I'll go ahead and do that. This is my new starting spot. And from that spot, instead of going over 1, up 1, like the parent table does, I'm going to go over 1, up 3, and it's going to be right there. Oops, no, I'm not. Did you catch that? It's upside down. It reflected. I'm going to go over 1, down 3. Okie doke. Next point would be typically over 4, up 2. But I'm going to have to go 3 times that. Instead of going up, I'm going down. So I'm going to go over 4, down 6. It's going to take me to right there. Next one, over 9, not up 3, but over 9, down 9. All right, so over 9, down 9 takes me to right here. All right, I think I'm going to be out of luck on the next one. It's going to end up off the graph. So let's go ahead and make this kind of sideways parabola looking thing, and then it's just headed that way. Okay, that's my last example in the notes. Now, if you were in class, then my next plan was maybe just start working a few of them together on our notes. On our homework. Your homework is going to be a worksheet on this so that you can actually have graphs to actually plot points nicely. If you're just watching the video, I guess go get started on that homework. Thanks for joining.